Earth remembers. It remembers in stone, in ice, in fossils, and in thin layers of dust left behind by catastrophes that happened millions of years before the first human civilization. A geologist can read those layers almost like pages, a change in isotope ratios, a sudden boundary rich in unusual elements, a species that appears, flourishes, and then disappears. This archive is incomplete, but it is physical. It can be measured. Human beings carry another archive, not in stone, but in stories. Across time, cultures have imagined or remembered floods, lost homelands, teachers descending from the heavens, giant beings between gods and humans, golden ages, forbidden knowledge, and civilizations destroyed after their power exceeded their wisdom. These stories are not geological samples. They are not interchangeable with scientific evidence, and that distinction will matter throughout this series. But what if the most interesting question is not whether the two archives perfectly match? What if the mismatch itself tells us where our map is incomplete? Welcome to Earth Classroom. In the Wisdom Bridge series, we moved from symmetry and matter toward life, consciousness, and responsibility. Now we step off that bridge and return to our own planet. Not to prove a hidden history, but to ask how different forms of memory can be compared without being confused. Imagine that two cameras record the same catastrophe. The first camera faces the event. It captures the shock wave, the chemistry of the debris, the temperature change, and the layer eventually deposited in the ground. Its question is, what physically happened? The second camera faces the survivors. It records terror, displacement, the collapse of a familiar world, and the warning carried into later generations. Its question is, what did this event mean to the people who lived through it? The cameras do not contain equivalent evidence. The second recording cannot tell us the chemistry of an impact, but the first recording cannot, by itself, reconstruct the human meaning that survived after the physical event had ended. One event can therefore leave more than one archive. The mistake begins when we force one archive to perform the work of the other. Sometimes a story may preserve a distorted memory of a real event. Sometimes it may preserve a psychological pattern. Sometimes it may simply be a story. Those possibilities cannot be collapsed into one another. That gives us our first rule. Similarity is not proof, and disagreement is not automatically error. Picture a cylinder suspended in a dark room. Shine a light from one side, and the cylinder casts a rectangular shadow. Shine another light from above, and it casts a circular shadow. The rectangle and the circle look incompatible, yet both are projections of the same object. No single projection contains the whole structure, but the difference between projections can reveal that our description is incomplete. We will call that difference a projection residual. This phrase must be handled carefully. A residual is not evidence that Atlantis existed. It is not proof that a metaphysical text is historically correct. It is simply a mismatch left when different descriptions fail to coincide. A residual is a reason to investigate, not permission to believe. This is where we enter more controversial territory. One source used in Earth Classroom is the Law of One, also known as the Ra material. Recorded in the early 1980s, the text presents itself as communication with an intelligence called Ra, described within the text as a sixth-density social memory complex. There is no established scientific evidence verifying that description, so we will not use it as a history textbook. We use it for a different reason. It contains a highly organized internal map of consciousness, choice, civilization, and power. Within that map, human life belongs to what the text calls third density, a stage in which self-awareness creates the possibility of meaningful choice. Civilizations then polarize along two broad orientations: service to others and service to self. Whether or not we accept the cosmology behind those terms, the structural question remains useful. When a civilization gains power, where does that power flow? Outward toward more autonomous participants, or inward toward fewer controlling nodes? This is not a fairy tale about good people and bad people. It is a question about network structure. A service to others pattern tends to distribute knowledge, agency, and the ability to participate. A service to self pattern tends to compress knowledge, resources, and decision-making toward the center. Real civilizations contain mixtures of both. Self-preservation is not the same as systemic extraction. Every living system needs boundaries, resources, and some ability to protect itself. The structural problem begins when preservation becomes unnecessary domination. When scarcity is maintained even after abundance is possible. When knowledge is withheld mainly to preserve hierarchy. Or when other participants are treated only as fuel for the center. The distinction is not between caring for oneself and caring for others. It is between sustaining a participant and converting every other participant into an instrument. This is where PTQ enters Earth Classroom, not as a machine for proving ancient legends, and not as permission to convert metaphysics into physics. Here, PTQ offers a geometric vocabulary for comparison. Imagine an idealized reference state, then imagine a system gradually moving away from it. We can represent that departure with a symbolic coordinate called epsilon. In this series, epsilon is an interpretive coordinate. It is not a measured archaeological field. Its purpose is to help us visualize change. A slowly changing epsilon represents gradual accumulation. A steepening slope represents accelerating differentiation. Local compression represents knowledge, resources, or authority becoming concentrated into fewer nodes. And a discontinuity represents a transition, collapse, catastrophe, institutional rupture, or the opening of a new evolutionary path. The important quantity may therefore not be a single value, it may be the slope. How quickly is the system changing? And where is the change accumulating? Concentration can initially look like efficiency. A network may appear faster when decisions, capital, and technical capacity gather inside a small number of powerful hubs. But concentration also changes how failure travels. Imagine a financial network in which risk has accumulated inside only a few deeply connected institutions. During stable periods, the structure may appear exceptionally productive. But when one critical hub fails, the shock no longer remains local. It can propagate through the entire network. This does not mean that every centralized structure must collapse. It means that concentration changes both the distribution of power and the geometry of vulnerability. History can then be read not only as a list of dates, but as a landscape of flows, bottlenecks, branching paths, and phase changes. There is another useful idea. Order matters. In a chemistry laboratory, the sequence of dilution matters because heat can be distributed differently depending on the order in which materials are combined. The ingredients may be the same, the sequence is not. This is only an analogy. It is not a PTQ derivation of history, but it gives us a concrete way to think about institutional sequence. Does a civilization first develop feedback, accountability, distributed access, and the ability to correct mistakes, and then introduce a technology capable of transforming the entire system? Or does that technology arrive first inside institutions already organized around secrecy, extraction, and concentrated control? The technology may be identical, the trajectory may not be. And this is why an investigation of lost civilizations suddenly matters now. Artificial intelligence is becoming an interface to knowledge, a multiplier of productive capacity, a tool for prediction, a tool for administration, and potentially a powerful amplifier of surveillance and control. Artificial intelligence does not arrive with a civilization ethic. Its social direction depends on architecture, ownership, incentives, governance, and the ability of ordinary people to question the systems acting upon them. Who controls the computation? Who chooses the objectives? Who can inspect the decisions? Who absorbs the failure? And who is allowed to leave? These are not ancient questions. They are questions of the present. This is also why the story of Atlantis retains its power, even if we set aside the question of whether any particular Atlantis narrative is historically true. As a civilization myth, it asks something brutally modern. What happens when technical capability grows faster than wisdom, empathy, and governance? The danger is not that a machine suddenly develops hatred. A system does not need hatred to cause harm. It only needs to optimize a narrow objective while the wider cost remains outside the metric. If an institution rewards extraction and concentrated control, artificial intelligence can make those processes faster, cheaper, and more scalable. If an institution rewards transparency, cooperation, correction, and shared benefit, artificial intelligence can strengthen those capacities instead. This is an ethical and institutional choice, not a proven law of physics. The machine amplifies the structure into which it is placed. Then, at scale, the amplification begins to reshape the people who built it. That is the question beneath the ruins. And now, the experiment is no longer safely buried in the past. We are inside it. Earth Classroom will therefore move through several different layers of information. Mainstream science will provide the anchors: geology, paleontology, archaeology, astronomy. The law of one will be treated as a metaphysical source. Broader esoteric traditions will be treated as cultural material, and PTQ will provide an experimental interpretive language for comparing patterns across those layers. They will not be given equal evidential weight. That separation is the map. With that map in hand, we can begin the journey. We will first return to 66 million years ago when an asteroid struck Earth and helped end the age of non-avian dinosaurs. We will ask what a genuine planetary discontinuity looks like when the evidence is written directly into rock. Later, we will encounter stories of cosmic gardeners, giants, Lemuria, and Atlantis. We will examine how knowledge becomes institutional power after catastrophe, and eventually we will return to the present, to artificial intelligence, to concentration, and to the possibility that an ancient story can remain useful even when we refuse to pretend that it is established history. Perhaps the deepest form of forgetting is not the loss of a continent. Perhaps it is the loss of a relationship. The idea that individuals and systems are not isolated from the structures they create. That technology does not choose a moral direction for us. It amplifies the direction already embedded in institutions, incentives, and human decisions. And that power without feedback can eventually damage the system that produced it. Imagine for a moment that most of our civilization disappears. Thousands of years from now, future archaeologists uncover the foundations of enormous server farms. They find corroded processors, fragments of fiber optic cable, and traces of algorithms whose original objectives can no longer be reconstructed. What story would they tell about us? Would this be remembered as an age that placed knowledge into more human hands? An age in which intelligence became a shared instrument for medicine, education, discovery, and cooperation? Or would they describe a civilization that built extraordinary systems, then allowed those systems to concentrate attention, wealth, knowledge, and decision-making into fewer and fewer centers? Perhaps they would call our server farms temples. Perhaps they would turn our corporate symbols into forgotten gods. Perhaps a technical failure would survive as a story of judgment. We cannot know. But the thought experiment reverses the direction of the question. Atlantis is no longer only a story we tell about the past. We are also a possible lost civilization in someone else's future, and the mythology they inherit from us is being written now, not only in our machines, but in the relationships those machines create. Earth Classroom will not ask you to believe every ancient story. It will ask something harder. Can we remain intellectually disciplined without becoming intellectually closed? Can we enter a mystery without pretending uncertainty has disappeared? And while the complete map is still hidden from us, can we decide what kind of civilization we want to build? Perhaps forgetting itself is part of that difficulty, not necessarily a cosmic design, not a fact we can prove, but a philosophical possibility. If we possessed a perfect answer key, would our choices reveal understanding or only obedience? In uncertainty, our decisions expose what we value. Perhaps that is the real examination. Not whether we can recover every memory of the past, but whether in an age of extraordinary power, we can remember what the power is for. Next time, 66 million years ago, a rock from space struck the Earth. One world ended, and inside the darkness, another future began.